lot of questions about what kind of equipment is best for starting a monitoring station or what equipment that we use. It's all going to be based on, of course, budgets. You can have millions of dollars or you could have hundreds of dollars, but it really doesn't matter what equipment, or I should say that the FCC, as an FCC agent, I can't endorse any specific model or any equipment, but I could just tell you what highlights that you can use when you're selecting the equipment that you may purchase or you may be already using. So the minimum equipment that you need to start any monitoring or a monitoring station would be a receiver or a spectrum analyzer. And in addition to that, you will need some type of antenna, whether it be omni or directional. Again, I'll get into some of the different receivers, some of the requirements. I'll show you some different antennas, some of the antennas that we use, and just give a highlight to those equipment. And if you have any questions, just let me know. So when we talk about receivers, there's different flavors of receivers. You can go as cheap and as expensive if you want. But when you talk about receivers, you can have portable receivers, you can have stationary receivers, fixed or transportable receivers, or even now you have the SDR, plug and play receivers. You have handheld receivers and scanners. No matter the manufacturer of the receiver, when you're picking a receiver for monitoring, you basically want to look at the sensitivity. The sensitivity is basically determines how good that receiver is at picking up weak signals. Bandwidth, how much spectrum do you want to look at in this receiver? The frequency range as well. What are the typical frequency ranges of your agency? For us field agents for the FCC, we like to say that we look at any frequency from DC to daylight. But for the most part, FCC agents in the field, we mainly looking at VHF, UHF. We're now getting into microwave, a lot of the CBRS, S-band, and some of the microwave radars as well. So we need to have equipment that are narrowband, bar-band that will be enough to enable us to look at some of the tasks that we have that come in based on the complaints that we're given. Within picking a receiver, you also want receivers that can give you some special requirements, such as a signal strength indicator, if it has a panoramic display, and whether it can be controlled external. Because some receivers you can attach to a laptop and you can control it via the PC, or you can have a receiver that you can control over the internet. So if it has an Ethernet port that you can control based via some software. I see a question regarding the difference between omni and directional antennas. I'll get to that when we get to the antenna portion. So next, beyond receivers, you have spectrum analyzers. And spectrum analyzers come in different flavors. And a spectrum analyzer basically allows you to see the spectrum. There's different types where you have a swept tune analyzer, which is an older type analyzer. And then you have the new digital FFT or real-time spectrum analyzers that would give you fast processing that would be able to catch bursty or quick signals. They come in different platforms. As you see the pictures here on the screen, in the upper left corner, we have an older swept tune analyzer. Then we have a portable handheld one. Then we have two of the newest kind, are USB type spectrum analyzers where you can plug into a PC and you can use the spectrum via a software. So that leads us into antennas. Antennas comes in different flavors, different frequency ranges, and different polarizations. Most antennas that commonly used in FCC field offices are dipoles, low periodic, Yagis, disc cone. We also have GPS, horn, loop, square slot, parabolic dish, and whip antennas. Just to add to the different choices of antennas, again, you want to choose an antenna based on the frequency range that you are looking at or hunting or monitoring, which could be MF, HF, VHF, UHF, or anything above 1 gigahertz. You also want to concern yourself with antenna polarity. Antenna polarity is whether it's vertically polarized or horizontally polarized. Also, the gain of the antenna, and then you have the directionality of the antenna. And the question asks, what was the difference between the omnidirectional and a directional antenna? Omnidirectional antenna radiates around all sides. So you will want to look at that if you don't know, if you're not concerned with any particular direction and you just want to view what the antenna can see, you will want to choose an omnidirectional antenna. Now, if you were concerned with trying to identify where the source of the signal that you're trying to trace, you will want a directional antenna where it has null within the antenna pattern where it isolates and only receives in certain directions. That helps when you're trying to DF or narrow down where a signal is coming from. So again, omnidirectional, it radiates in all sides and can receive signals in all directions. And a directional antenna receives signals in one direction, which helps with identifying where a signal source is coming from. Again, both has their advantages and disadvantages when you consider monitoring. More so with monitoring, in our course of our work, I would start with an Omni just to make sure that I can see a signal, and then I will switch to a directional antenna when I want to narrow it down and try to trace where that signal is coming from. Again, with the other choices, you have broadband versus narrowband. And what that means, I'm talking about the frequency range. If I'm looking at 100 megahertz or the 1,000 megahertz, you want to make sure you pick the antenna that cover the ranges that you want to receive. Again, it goes back to flexibility. A lot of times as field agents, we carry a lot of equipment out in the field. So if I can reduce the amount of equipment that I carry, where I can eliminate carrying 5 antennas as I can carry one antenna that covers multiple frequency ranges, that will be ideal. But sometimes based on antenna gain or terrain, certain antennas may be preferable over others. And that's when we get into mobility. Where do I want a permanently fixed antenna? Do I want a temporarily mounted antenna? Or do I want a mag mount that I may be able to stick on top of a vehicle to drive around, or on top of a building to give me height? It all will depend on your investigation task, your monitoring task, and the terrain and environment that you're find yourself in. And again, to cover yourself, it's always best to use a multi-band antenna. That way you don't eliminate some of the resources that you have to lug around the equipment.
There was one more question there.
Okay.
So what about satellite spectrum? Does the FCC monitor high bands for satellite services like FSS, MSSE, SS? What type of equipment did you use?
Yeah. So not my bureau, the FCC Enforcement Bureau. We used to have a satellite engineer that monitors satellite, that does monitor those spectrum. And we also have FCC Space Bureau now that also monitor or deals with satellite. I'm not that versed on what equipment that they have, but I do know they have a couple big dishes down in the field here. That's the KU band and some of the other satellite bands. I don't know what they do today to give you more information, but I do know that we do have satellite equipment here on site in Columbia, and we have some satellite engineers that do monitor and regulate satellite services. Okay. I see another question. When do you use the fixed monitoring station? So we use fixed monitoring stations based on, again, we are complaint driven. So it depends on the complaint or the investigation. We have some complaints where it's intermittent, where we cannot be there all the time. So we have portable fixed stations that we deploy. I'll get into that when we get to some of the FCC tools, but we do use fixed stations. We don't have enough to my liking. We used to have multiple fixed stations in and around our own area that enabled us to be effective monitoring, but fixed stations are well to have, and we do have a complement of fixed and mobile stations, and then I'll get into that when we talk about some of the equipment. Another question regarding USB analyzers. Some USB analyzers are limited to certain frequency bands. You can find ones that cover a wide range. I do believe most of them may stop at 1 gig or maybe 2 gigs. It depends on the manufacturer. They're developing different ones that do higher bands, and there may be some other additional equipment that will allow you to extend the range of some of those analyzers. But you do have to be concerned with some of the limitations of USB analyzers are that they're susceptible to overload. You will want to look at the specs of that analyzer before you deploy it to make sure you fortify that it won't destroy it if you're looking at some high power signals that comes in to those type of analyzers. Now, to get back to some of the spectrum monitoring investigation tools that we use at the FCC, we talked about spectrum analyzers. Again, spectrum analyzers are basically used for signal classification. We do use those for some frequency measurements, whether it's bandwidth measurements, emission mass measurements, some other type of compliance measurements. We will use spectrum analyzers. For monitoring receivers, we typically use those for demodulation, also for signal classification, also signal IDing. Sometimes you can record IQ data and regenerate the signal. We also use portable monitoring equipment such as the TCI, Blackbird. We also have the Rotary-Schwartz SEPTA program. It's Rotary-Schwartz DDF. We also have some Keysight equipment as well that allows you to deploy a system where you can actually sit from your office and monitor equipment from anywhere in the world or in any area that has a stable internet connection. We also talked about difference between different antennas, but what also we like to implement or like to tell people that most people don't think about is some of the ancillary equipment that will help you and enable you to do your job better, which is some filters and low noise amplifiers. You want some filters, preferably some bandpass filters, to allow you to eliminate signals that you don't want to view or to isolate your analyzers from susceptible to being overloaded and get rid of some intermodulation that may occur if you're in higher RF environments. You may also want to use some low noise amplifiers when you're looking at microwave and you're looking at some of these higher frequencies. And if you're using handheld equipment to increase your sensitivity, you may want to use a low noise amplifier to boost your range and give you some additional sensitivity so you can find those weaker or quick bursting signals that allow you to DF it a little better. Also, cameras. Cameras are important. And you might say, why do I need a camera for spectrum monitoring? You may need it to take a picture, capture evidence for an antenna or location where you want to come back and monitor it. And sometimes the cameras have GPS, so you can note your location and what you were looking at or at a specific monitoring point. Rangefinders are good for determining how far you're away from a particular object. It could be a building, it could be tower site, and that's good for if you're doing measurements to calculate your distance. If you're doing some hand calculations or you have some spreadsheet that needs distance for the equation for you to determine the power. Night vision goggles as well. That allows you, if you're doing some monitoring at night, you can see certain objects, and field strength measurements, field strength meters, as I should say, that allow you to make over the air measurements where you can make these measurements without actually contacting licensee or operator to see if they're in compliance with certain kind of field strength rules based on FCC rules or ITU rules, or you may have your own rules regarding over the air requirements. Let me get to some of the questions. Do you have microwave deployment in E-band? Not that I know of for the field. We haven't gotten to 70 gigahertz as much. We don't get that many complaints in those higher bands. How do you pinpoint an interference when you're using a spectral analyzer in the field? Good question, Joseph. We'll get to that a little later where we talk about handheld DFing and some of the techniques to using the spectrum analyzer or a receiver to pinpoint interference. Muhammad had a question regarding difference between omnidirectional and directional in detection, and could one compensate for another? Yes. So if you, again, omnidirectional antenna radiates in all different directions. If you're trying to isolate a signal source, you will want to use a directional antenna. So that way you can pinpoint where the strongest signal is coming from. Now, if you don't have a directional antenna and you have an Omni, you still can pinpoint where the source is coming from, but it will be a little harder and a little longer to do that. But how you would do that would be by looking at the signal level. You can, based on signal levels from where you take different measurements at certain spots, based on the signal level, you can just keep moving around to see if the signal level increases or decreases with your movements, and that can give you an indication of where that signal is coming from. Now, if you're trying to make a compliance measurement, it depends on the type of measurement that you're making. You may want to use an Omni versus directional antenna because you want to make sure that you're receiving the signals in all directions. So if I'm making a field strength measurement or I'm making a radiation measurement, which cause most of the probes are triaxial, so you want to receive the signal in all directions, Omni will be preferred over a directional antenna. It all will depends on the task that you're using the antenna for will determine what's the best and appropriate antenna to use. All right, one more question before we get into interference. Do you have a special equipment for mobile source interference like DPMR? So again, yes. So we do have special equipment for digital radios, or whether it's DMR, P25. You can use, or they have AOR scanners. They have ICOM radios that can decode those digital radios. We have a ICOM radio that we receiver that allows us to decode or get the channel color code or maybe the NAT code of the digital signal that will allow us to help us determine the operator, or at least hear what they're transmitting to help us determine who's maybe the source. Again, antenna question on antennas. Which antenna is better recommended for VHF? Again, it depends on what you're looking for in VHF. It could be a whip antenna. Again, that's an omnidirectional antenna that allows you to receive signals in all directions. It could be a standard little meg mount, a telescoping dipole. It depends, but that would probably be the one I would use. I would start with a little whip antenna or possibly a monopole dipole in the VHF range to begin monitoring VHF. Another question: how do you monitor and resolve cross-border interference? Basically, cross-border interference, we work with our cross-border partners. When we talk about interference and how to locate a source, it's based upon monitoring, developing, building a pattern, building information to determine where exactly that signal is coming from. If we get indications or we get bearings that it's coming across the border from Canada or Mexico, we have to make sure that we use all available tools to ensure that we know with 100% certainty that it is coming from across the border. And then we'll work with our international partners to come up with some kind of coordination or some additional testing to try to verify and resolve those issues. Okay. So that was a good segue to interference. Before we can determine interference, it's also good to identify or classify what the FCC determined is interference. So the FCC determines interference as any unwanted emission or energy that radiates or cause performance degradation or loss of information to a particular service. Again, we also have a high priority for what we classify as harmful interference. And harmful interference is any interference that endangers public safety of life and seriously degrades communications and services that will render it hazardous to the public or our industry. We consider that as harmful, and that's a main priority. It's something that we want to identify and we want to resolve as soon as possible. So with RF interference comes in different sources and different forms. Try to highlight some of the different and give you guys different classifications and some of the typical interference issues. As many interference, I can't identify all of them, but I'll give you some basic ones. With those basic ones that I provide to you today, that'll give you a head start and trying to help identify interference. And just knowing some of these tips will help you give you some hindsight, because interference can be tricky. It can be time consuming and it could eat up a lot of resources. However, techniques that you develop on your own or techniques that you develop from your teammates or even from me goes a long way in trying to resolve some of these interference issues. And resolving interference is always information sharing is the best key to help minimizing interference. So again, interference comes in different shapes and forms. Before we, as the FCC, can investigate interference and we get complaints, we have to determine whether it's internal or external. Internal interference is basically interference that is generated by the complainant, the person that's filing the complaint. We require that they go through their equipment and make sure that their equipment is functionally sound, it's nothing broken, they're not having any issues. If they had any issues, that they resolve those issues to ensure that the source of interference is not their own equipment. And that leads us to external interference. So external interference is any interference or any signal that emanates from the environment or from another radio system that causes disruption or causes problems to that person that's filing the complaint. So we do not resolve any internal sources. We only investigate external sources of interference. So what are the general symptoms of interference? So if you have issues or you get complaints where the user say they cannot communicate in certain areas, or when they cannot communicate in places where they usually communicate in, or they are having issues at multiple different sites, and even they try to switch out equipment and they still having the same issue. If they're in a particular area and they move out of the area and the situation improves, that could be a sign that you're having localized interference in a particular area. Or you're monitoring and you observe some unknown transmissions that typically aren't there and it's not from your system or the person that's complaining system. So again, the FCC is complaint driven. So we rely on getting as much information as possible from the complainant to help us determine where the interference is or how we can determine what assets and resources that we need to use to deploy to help resolve this interference. So the best thing that we can get is try to get the complainant to issue or start generating some kind of log of interference to help us help them. And within that log, we want to determine date, time, a frequency band. Is there a certain channel, the center frequency? If they're able to determine how strong of a signal that they're observing, do they know how much bandwidth the signal is being disrupted? Can they demodulate a signal? If can they hear a call sign? Can they hear a station ID? Is it someone talking? Is it Morse code or some kind of identifier that's being broadcasted that will help us try to narrow down, or a particular sound of the signal source? Can it go a long way in helping us try to resolve the interference? Also, the patterns. Is it consistent? Is it intermittent? Does it happen at a certain time of day? Do it happen at a certain time of the year? Do it happens when it's cold, or do it happens when it's rain, or do it happens when it's dry? And how long? The duration is big, and us determining whether we want to have an agent on site or do we want to deploy some kind of remote equipment that will enable us to help gather some of this data that we need to fill out this log to help us resolve the interference. All right. Before I go into the causes of interference, let me jump back in the Q&A to see if any questions. Can I detect the unauthorized uplink satellite terminal using a fixed monitoring station, or would it take another method or technique? Again, I'm not a satellite engineer, so I don't deal with much satellite unless it's Earth-based. You can, it is ways, but the wouldn't want to lead you in the wrong path is just something that we don't do. Question: how does frequency monitoring work for terrestrial radio broadcasting in 11 and 12 gigahertz band? Again, for frequency monitoring, even in 11 gigahertz band, we have a lot of wireless internet service providers that use 11 gigahertz for backhauls, and that's pinpoint. A lot of times you have to plot out where those licensees are so you know where they're broadcasting or what their transmission paths are. And a lot of times if they're having interference, is usually localized to one particular site or in a path of one link to the next link. So ideally, you will want to get some kind of elevation. Maybe you want to tap into their antenna to see what they're seeing. And then you start at the, I hate to say victim site, but the complainant site, and you try to tap into their antenna, and then you try to see what they see, and then you try to go make different measurements or different monitoring at different points along that path. And getting high up is ideal, but if you can't get high up, then that's when you want to use some of the ancillary equipment that I mentioned before, where you will want to use a high gain antenna, preferably a horn, since you're looking in the microwave band, maybe a parabolic dish, and you want a bandpass filter and an LNA to give you some sensitivity so you can mimic what the complainant's receive site sees. So you can see that on the ground, and that can enable you to try to narrow it down on the ground, or maybe you can have some fixed equipment that maybe you can deploy on rooftops or high elevations and scan the horizon to see if you can narrow down where the source is. But I always start at the victim site and try to see what they see and then work from there. How do you monitor RFI on GNS signals? So here, again, you monitor the GPS bands. Again, you will use filters and antennas. Again, you want to have analyzer or receiver that's quick and able to have a good sensitivity to see some of those signals. And again, you start from where it is here, and nothing really should be on GPS other than that. And if I'll talk about GPS jamming and some other issues later on that may be able to help you with that. How do you handle TDD interference? That's a good question. We have a lot of TDD interference from cell phone providers. What I've come to find that helps is a good analyzer, and you want to have an analyzer that has or nowadays they have analyzers that have options for over the air TDD measurements. They also have TDD gating that allows you to split the uplink and downlink. That way you can see the interference without having the system shut down. And also doing that is one way to have the complainant shut down so you can see what interference comes in. But a lot of times for cell phone providers, they don't want to turn their systems off. So these different spectrum analyzers or receivers that have TDD options or TDD gating that allows you to split the uplink and downlink will allow you to narrow down the receivers. Also, they have certain spectrum analyzers that have RF over CPRI that allows you to tap in via fiber to some of these different TDD systems to look at live over the air without interrupting the system to see the interference. Next question. In the event of self-interference, internal interference, do you penalize the operator for causing interference? No, we do not. We don't penalize them because sometimes they don't know. They don't know that their system is working incorrectly. Sometimes it's just they haven't had done any preventative maintenance on the system. We try to narrow it down, and then we don't want to be their technicians to tell them actually what is wrong with or why they're having self interference. We just tell them to work with their vendor or manufacturer of the equipment to resolve whatever issues that may be causing the interference. But we do not penalize them for filing a complaint once we deem that they're the issue of their own complaint. According to your experience, what is the best equipment that you could use for monitoring any special brand? Again, Yvonne, I can't endorse any particular equipment. Here with the FCC, we use all different brands. It depends on the agent. Each agent may have a particular device that they may use over the other, not meaning that it's the best. It's just that they prefer one brand or one particular device over another. But pretty much they all do the same. You just got to learn how to use them. And sometimes the ones that people say aren't any good are, they just have their own biases against a particular brand or flavor. But it all going to depends on your budget and what you can afford. And even us, I will prefer a lot of different equipment that we don't actually get, but you make use of what you got and make it work for you. The next question, how can we identify a number of interfering radio devices per frequency channel? So when we talk about identifying number of sources per frequency channel, you will want to have some kind of special monitoring equipment. That equipment, you can have it scan certain frequencies. You can see what comes in. Again, I'll talk about different types of interference that could lead you into determining certain types of interference. That'll be a segue in the different causes of interference. But some type of monitoring software, in addition to a spectrum analyzer, could help you narrow down different interferences based on the frequency channels.
And Shannon, I just wanted to just jump in. If you think that you're, again, going to address some of these questions in your presentation, I just want to be mindful of the time.
Okay, no problem.
Thank you.
All right, the last one. Do you use a fixed station for monitoring or only portable and mobile? No. So yes, we use both. We used to have fixed sites here in Columbia where we would use it in conjunction with the portable and mobile. Now we use all three. So depends on the fixed station sometimes help us identify a location or where we need to deploy the mobile and other portable devices. So we have a fixed station. I would like to use it. And then we put temporary fixed stations up in conjunction with our mobile platforms to help us narrow down and isolate, triangulate on signals quicker. All right. So I think some of these other questions I'll get to inside the presentation. So since we're talking about interference again and how we find interference, we got to know the different characteristics of some interference, and that will help you determine whether it's internal or external, given on the characteristics or behaviors of what the interference is being classified as. So we have, and then that will tell you what techniques you may need to use to implement to help you resolve those interferences. So we have some key types of interference where we have co-channel interference, adjacent channel, intermod, spurious emissions, harmonics, electrical or power line noise, signal boosters, and jammers. So the first type of interference I want to bring to your attention, co-channel interference. Co-channel interference is basically you have two different radio transmitters that operate on the same channel. And generally one they suppose based on license or allocations, they should be allocated. There should be some kind of separation distance where they don't interfere with each other, but that doesn't always happen, where you may have one far off station that's interfering with another station based on atmosphere propagation, or somebody just put something up that in the wrong location. But you have two systems that are operating on the same channel. Again, depending on the parameters and how the channel is allocated or licenses is authorized, we'll like to talk to each of the co-channel users, and we'll try to see what the license says about who or frequency, power, antenna specs to see if any of that can be adjusted. We also can recommend whether reduction of power, if it's a land mobile system, adding PL tones. It's just basically tones on the receiver based on you having the same operators on the same frequency, and a PL tone eliminate the other user from hearing it unless they're using the same frequency and the same PL tones, but adding a PL tone will allow them to operate on the same frequency without using each other, hearing each other. There's also squelch or threshold adjustments where we can see that maybe they can hear it, but it's at a lower level that it's coming in and causing them an issue. And maybe adding 2 to 3 dB of attenuation may knock it down enough where they don't hear it, or maybe changing the antenna or lowering the gain of the antenna or lowering the height of the antenna will minimize, or possibly even changing the direction of the antenna. Just changing the direction of the antenna 1 to 2 degrees can help with minimizing interference. And that's some of the recommendations that we typically give for trying to resolve co-channel interference. The next type of interference is adjacent channel interference. So this is basically you're getting interference from a neighboring transmitter that may be off maybe a couple kilohertz or maybe a meg away. First, we want to determine that everybody is operating within their license parameters. And then we want to make sure that the offender is not operating over power. Then we want to determine what is the cause of them being affecting their neighbor. So again, the first step of resolving this type of interference is, again, to make sure all parties are operating within the FCC limits. And then we'll suggest possibly seeing if they can add a filter to see if that will add with eliminating or reducing the unwanted transmission from affecting the adjacent user. Next type of interference is intermodulation or intermod. This is a result of 2 or more signals appearing in a long linear circuit. You can't have intermod without two signals. The screenshot provided here shows you have 2 signals, A and B. You only can have intermod when those 2 main signals are active. When those 2 main signals are active, they create different products that's above or below the operating ranges of the 2 main signals. Again, they only can be active when those 2 main signals are active. Again, this is a screenshot that shows 2 active signals in the 400 megahertz band that creates 2 intermod products. Again, the intermod is difficult to resolve because you have to look at not only the complainant's frequency, you have to have an overall view of what it looks like within the spectrum. But you also can do some intermod calculations that help you narrow down what product will be produced at what frequency range. Again, we want to make sure that everybody and that the equipment itself is not creating these type of equipment. This type of issues. So once we verify that the equipment is in working order, we look at the spectrum. And then if we see 2 signals, and then only when we monitor for a while and we say, hey, this interference only happens when A and B are active at the same time. And then we could do some calculations or we'll do some monitoring, and we could see that these 2 products rise and falls when these 2 systems are active at the same time. Again, then in that case, we would determine that it's likely from intermod, and then we would suggest that they try to add some type of filtering, or sometimes they have filtering, but we find that the tower or the transmitter site doesn't have enough grounding or improper grounding. A lot of sites here in the States, we have copper thieves, so a lot of the grounding are with copper wires, and a lot of people will go in and instill copper off of towers, and that will create some grounding issues that can cause intermod. The next interference issue is spurious emissions, or we call spur. So this is a signal that's emitted outside of the transmitter assigned channel. It could be anywhere in the band or within the frequency range. Here we have a screenshot where we have a 152 megahertz pager that was emitting a spur on 156.8, which is 4 megahertz, almost 5 megahertz away, that was causing interference to the Coast Guard. And we monitored, we looked at the offending signal, and we saw a signal that typically is not the normal signal that should be in that band. We also listened to audio. I don't know if you guys ever heard a two-tone pagers, but it is very distinct when you hear it. And we heard that it was a pager, so we spanned out and start looking at the band where pagers are typically located, and we watched both frequencies. And when that pager was active, we saw a spur, a low-level signal that was generated on the Marine channel when that pager was active. So we found out that was spurious emissions from that pager. We traced it down to the pager site, and then we had them turn it off. And we had them for spurious emissions is a defect or something went wrong in the transmitter that needs to be repaired or replaced. Next type of interference is harmonics. So harmonics is basically, it's physics. There's nothing that we can do about it because it's naturally going to occur. So you have a fundamental one frequency that's n carriers away from the fundamental. It tends to drop, which each level it goes up or down. Here we have an example where we had a transmitter at 192.25 megahertz that produced a fourth harmonic at 781. 781 is in the LTE band. And so we had a complaint from a cell phone carrier that they were seeing a narrow band signal within their band. So this is their band where they receive in. So it shouldn't be there, this narrow band source. We looked at both spectrums, and then we DF'd the source to a particular transmitter. We looked at the licenses, and they didn't have any license for 700 megahertz, but they did have a license for VHF. So we looked at the VHF band, and we noted that this signal was active with this 195 megahertz transmitter. We did what we call an on-off test, and when we turned that transmitter off, the source on the complainant went away. So we determined that this was a harmonic from this transmitter. Again, adding attenuation or bandpass filtering would be the recommendation to try to help reduce the harmonic or minimize it to a certain level where it's not causing interference. The next source of interference or type that can cause interference is electrical noise or power line noise or electrical noise from equipment. We see a lot of sources of interference from motors, fluorescent lights, power supplies, high voltage equipment. Again, with power line noise, it can tend to generate from equipment on a utility pole. We typically work with the utility company to try to isolate where it's coming at on the pole, and to get them to repair or replace some of the parts that may be contributing to the interference. So here we have graphical representation of a particular utility pole, and highlighted as some of the different components that fails that can generate interference. On the right, we have a spectrum screenshot of the amateur band. And a lot of times we get complaints from amateurs that says that they hear static and it's coming from a utility pole. A lot of times we go out within the area, we try to get information from the complainant or where they're hearing it, and it's usually at their home or wherever they have their radio site. And then typically they'll do some kind of the legwork themselves, and then they'll identify the pole or they'll identify the company. And usually it's a static sound or hum, and we use some equipment to narrow down where it's coming from and isolate a particular component. And then we'll get back with the utility company to help isolate that kind of interference. And here's some of the typical equipment that we use to help us resolve power line interference, or at least look at it or hear it. We have what we call sonic ears, or this company, Radar Engineer, sells a lot of equipment to help isolate power line noise. If you don't have this type of equipment, you can isolate power line noise with simple AM radio. Just tune it up and just walk. And as you hear it walk past power lines, it will get louder, or you'll hear the static, and it'll start picking up the interference as well. So that's a cheap way of doing it if you don't have these types of interference. Again, if you have a specialized receiver or a spectrum analyzer that can go down into that HF range, that will help you listen, see, and narrow down certain power line interference. Also, the Amateur Radio League also has a lot of different white papers and tech tips for and techniques for locating these type of interference, and that will be a good resource of information on equipment and techniques for trying to isolate and resolve power line noise and electrical noise in general. The next one is one that I particularly don't care for. We have a lot of problems with our signal boosters, or BDAs. These BDAs are particularly put in buildings to increase coverage within the building, but a lot of times they're either malfunctioning or improperly configured, and they cause interference to wireless networks, public safety entities, where they're supposed to increase your chances of getting calls inside buildings, but a lot of times they prevent you or block you from getting signals inside buildings. We have ways that we resolve these interference, but if we find a BDA, once we want to make sure that it's configured right, and if it's caused isolating, then it needs to be replaced. And then sometimes it's just power adjustment or antenna separation will resolve these types of interference from these devices. And this is an example of a signal booster that I found in a building. A commercial entity purchased this device. One, this device was uncertified. They purchased this device from Amazon. Yeah, I don't know if you could see the numbers on the device, but you could see that it had a 48 dB gain, a 16 dB output, which is too high for this consumer device. And it was causing interference to Verizon in the uplink. Again, we narrowed down, we DF'd where it was coming from. We looked at the equipment and found out that it wasn't certified, so it should not have been used in the US at all, but it was grossly adjusted, and we had this device removed. This is another example of a public safety BDA. Typically, public safety BDAs are red in color. Again, these are installed to enable public safety agencies, police, fire, different federal agencies to be able to use their radios inside buildings or different locations. Again, these are intended to increase coverage inside the building. It's not supposed to radiate outside. But then you see on the right, you have a nasty screenshot of this particular device, and this was observed miles away, and this was wideband. It was knocking down 10 to 14 channels of a system that was totally wreaking havoc on one particular public safety agency, caused by a device that was misconfigured and not working correctly. The next source or a type of interference can be due to jamming. Jamming is not allowed in the US. Jammers are illegal. If we find a jammer, they must be shut down. We, as the FCC, are not allowed to jam ourselves. And there are certain instances where the military or the president may be allowed to jam. But other than that, jammers are forbidden. But jammers basically do what they say they do, is they jam. Their purpose is to block you from receiving any kind of communications or signals. And they can be customized to jam pretty much anything from cell phone, Wi-Fi, GPS, VHF, UHF. We've seen them all, and we have found different jammers for different things. I don't know why, but they make their way in the country. They can be concealed. They can be mislabeled, and people use them. And they can be dangerous if they fall in the wrong hands. This is a jammer, a GPS jammer that was plugged into a vehicle. The person intended to block their asset tracking from their company. And this screenshot on the right shows that it was emanating in the GPS L1 frequency. Again, how we found this, we had a complaint. It was actually near airport where they were losing GPS every so often on a certain. We developed a pattern. We set up some monitoring equipment to observe this, and typically you will not see any kind of emissions in this band. But then we monitored, and over the course of a couple of days, we kept seeing this signature of this wideband signal within this band that should not have been there. And we located it, and then we set up equipment, and then we set some mobile agents in the area, and we were able to determine where this source was emanating. Here we have a image of a multi-band jammer. Again, the multi-band jammer will jam multiple bands, and typically you can tell a multi-band jammer by the number of antennas. Each one of these antennas will jam a different frequency service. So the more antennas that you see on the jammer is likely to jam multiple and different radio services based on the number of antennas. This one has 5. We recently found one that was jamming 30 different frequency bands. Again, you will see a wideband signal. It's nothing to it. It doesn't sound like anything. If you try to demodulate it, it's just wideband noise meant to block the transmissions from being received. And this example was this jammer that was jamming this 800 megahertz cell phone band. All right. So before I get into techniques on signal analysis, I would like to answer, make sure I get any questions.
We had quite a few questions that came in.
Let's see. Is there special monitoring equipment or measuring methods for maritime interference? No, you can use a typical receiver. Anything that again, you want to choose anything within that maritime frequency range. We get a lot of Coast Guard interference cases, especially during the boating seasons. So we just use a typical VHF receiver or spectrum analyzer, and we monitor those bands. And if we see anything out of the ordinary, or we get reports of something, so a lot of times we get boaters who will have faulty equipment, or they'll have stuck mics, or you may have an intruder, or they may have their emergency beacon for whatever reason that's faulty on their boat that causes interference. So we just monitor the band, and then we try to narrow down where it's coming from. We can only investigate stuff on land. So we feel that it's something in a vessel or something that's in the water, then we'll refer that to United States Coast Guard, and then they will DF that, or they will try to resolve it, anything that's in the water. But anything that's docked, we'll try to resolve that issue. But basically, using some of the equipment that I mentioned here, we use to resolve some maritime interference. Let's see. In the event of
a couple questions on from the airports. Maybe get a little of your time together. Aviation.
Okay. How can you tell us about airport stations for monitoring DF? Again,
was many problems interference with civil aviation, sometimes harmonics and broadcasting FM on the aeronautical band. How to solve those during aircraft calibration where landing. The calibration aircraft wants signal whenever landing. Can this interference attributed to passive objects within the airport perimeter, or is there other possible causes?
Yes. So in the U.S., we partner with the FAA, the Federal Aviation Administration. They have their own equipment as well that can pinpoint anything on the airport. They will try to resolve using the same techniques that we use. Anything outside the airport they'll bring us in and try to help. So whether it's again the harmonics from FM broadcast station or private radio operators that's using equipment that they shouldn't, or that has harmonic or spurious emissions, we do those. We monitor the aviation band. Again, if you hear music on the aviation band, you know it should not be there. If pilots report hearing music while they're flying over certain towers, then that can indicate if they can give us a call sign or content or recording of what they're hearing, we can try to pinpoint what possibly could be a licensee in the area. If there's no licensees in the area, then we'll generally go in that area and monitor to see if we can pick it up, and then we can isolate it from there to try to resolve it. For aircraft, that's a lot of times we do have where they lose certifications. And again, the FAA will handle most of those kind of interference issues with landing equipment or calibration. But if it's something outside of the airport, then they will bring us in, or we'll work in conjunction and try to work together to see if we can put our heads together to figure out where it's coming from. So that's a collaboration and information sharing that will help us resolve that and pool our resources together to help us resolve that type of interference. Have you ever switched off the victim emission in order to locate the co-channel interference? Yes. A lot of times you will have to cut off the victim, or we'll try to see if they can move to another frequency that allow us to be able to hunt the interference. Because a lot of times if they're active, we can't tell if it's them or if it's the actual other user. So with them being off, that will help us isolate where that user is, and then we'll determine if that co-channel user is legitimate or is somebody that may hijack their frequency that's on that frequency that's not supposed to be there. Are these illegal boosters or illegal? How do you deal with them? So some of the boosters are not illegal. Some of them are licensed to be used. Well, we have a process we have two different grades of boosters. We have consumer boosters, and then we have public safety boosters. The consumer boosters, you must have consent from the cell phone carriers or of all the carriers with which this booster will intend to boost that frequency range. For public safety or Part 90 or industrial boosters, again, you must have consent for the licensee to retransmit those frequencies. If you don't have consent, then you're not allowed to transmit until you get consent from these licensees. And then the illegal ones are the ones that aren't type accepted and not approved. Those will deem to be illegal. And we do find a lot of those. But for the most part, a lot of the ones that we find are legal. They just didn't go through the proper process to get consent before they can actually use them. What techniques do you use to locate sources in the urban environment, considering multipath and scattering nature of such environments? I'll get into that one when we talk about the techniques. That will good segue into where we are currently headed. With monitoring equipment, is it mandatory to use low loss cables? It's not mandatory just for monitoring, but when you're using certain cables for certain measurements, you do want to know your cable loss, because knowing those losses will add into your calculations of trying to determine compliance or not. So necessarily for monitoring, no, it's not. It would help, yes, but it's a mandatory no. It mainly comes into play when you're trying to make measurements or compliance measurements. You will want the least amount of losses possible. Is it recommended to install a fixed monitoring site on a site with multiple antennas in line with interference? So more than likely, when you're installing a fixed monitoring site, you want as much as you can to have a clean environment as possible. You don't want to be susceptible to other high power sources or anything that could cause any interference or harmonics. If that's your only choice, then again, I would suggest that you have some kind of isolation from those other antennas where they don't desensitize your equipment. So it's some little work that you have to do if you're installing it in those type of environments where you have a bunch of antenna or transmitting antennas. What's the simplest technique to resolve between two FM stations with neighboring assigned frequencies? Again, if you have two stations and they're neighboring and they both are assigned, one, you have to make sure that they're operating within their particular power limits. You want to make sure that one station is not overmodulated. You want to make sure they're within their power. You want to make sure they're using the correct antennas based on their license. And it's basically start looking at their licenses and then see if you find any discrepancies. If you don't find any discrepancies and filtering doesn't work, then possibly maybe somebody relocating or changing frequency or possibly moving a transmitter location to try to see if that will resolve the issue. A lot of times when we find those type of issues, we have a different department, which is the Meter Bureau, that will handle licensing. So we find that it's nothing technical that we can do as far as field agents and finding anything that would be causing them issues. Maybe it's time for the licensing to look at to see what they can do to change any parameters based on the license that will help alleviate that problem. And what about a couple about cross-border interference? What will be your key recommendation if the neighbors don't want to collaborate? That's a tricky part for us. So we try to work with the different entities or our sister agencies across the border in Canada or Mexico. Even within the United States, we have, especially here in DC, we have a lot of embassies from around the world. So even though they're in DC, the embassy is still considered a foreign entity. So if we find something that's coming from an embassy or a cross border, we'll try to work with them directly. If we cannot work or resolve, then we have what we call the United States State Department that will have diplomats to try to work out and get them to work with us. And typically it work just coordination and some discussions that got to be had to some kind of understanding that we need to resolve this as amicable possible.
And that's a tricky relationship when they don't want to necessarily come to the table and solve or kind of solve these disputes.
Yeah.
There's certainly an issue that happens abroad from the U.S., given we only have two borders. Yeah, definitely a great point on addressing it diplomatically is the first course of action, and in most cases will lead to some resolution.
Yep. So let me answer one more question. In case of C-band satellite downlink interference, do you know that you are interfered with 5G frequencies? Is that equipment or device can be used to isolate 5G interference? Yes. So we have seen a lot of, especially during some events, we see C-band or 5G interference between different carriers. Again, you use a spectrum analyzer or monitoring receiver. Again, if you have that TDD, a lot of that is TDD systems, you will use hopefully those kind of features. And then they have different devices that can read or scan 5G systems that give you the PCIs, to give you the metrics of the certain 5G operators that you can see whether they're operating in this band that could be causing interference. We recently found cell sites that was operating within their license parameters, but it was a misbehaving radio head that was generating in that C-band area. And we just went through some of the methods or some of the methods or techniques that I'm going to segue into right now to look at the band, look at the frequency and determine some signatures to help us determine where it is. And then we get into how we locate these different sources. So that was a good question to segue into spectrum analyzer basic techniques for interference signal analysis. We'll talk about measuring techniques, basics rather, frequency markers, max hold, spectrogram waterfall, RTSA mode, and locating sources. So again, like I said, in FCC, we can't endorse any particular product or analyzer. They all operate the same way. There may be some minor differences, but they all have the same basics. So when you get an interference complaint or you want to start monitoring to see if you see any interference, you want to turn to the center frequency of the signal of interest. As a zoom feature, I always like to put it in the auto. That way you can get the best view of the signal as well as the reference level. You can also put that in the auto as well to help you get started, and then you can adjust it from there. So this is just a screenshot of just a basic analyzer. The first things you want to look for, you want to set your frequency and span. Again, the frequency is you want to set it to a signal of interest. The span is how wide or how much bandwidth you want to look at. And then you have your amplitude and bandwidth and sweep settings. It's always general to start in auto, and then you can adjust it once you get more comfortable with the instrument. Another tool to use when you're using a spectrum analyzer is frequency markers. Here we have a bunch of signals, of different narrowband signals, and the markers will allow you to help quickly identify the signals, what frequency they operating on, and the power level. And then you can do some adjustments with delta markers where you can determine the difference between the peaks and how far apart these signals are. Another good feature to familiarize yourself with spectrum monitoring and inference hunting is the max hold function. The max hold function is the red line that you see in the picture there. It allows you to see where the maximum signal occurred. So say this peak here at 870 had peaked, but if you see the real time, the yellow line is no longer there. That could have been an intermittent or bursting signal that you didn't see before, or it was too quick to capture. But utilizing the max hold, you can see how strong that signal was when it did pop up. That way you can adjust and zoom in and set it to monitor or trigger the next time that signal pops up. Another useful tool to use on even a monitoring receiver or a spectrum analyzer is the spectrogram. Some people call it a waterfall. In the waterfall, you have the split between frequency and time. This is useful, like I said, if it's something intermittent and there's something that happens over a lot of time, and usually logs, and you can go back and look at frequency as opposed to time. And based on the log, you can see whether it was a continuous signal, or you could see whether it was intermittent, or you could see in the waterfall whether it was just a single event. So this is good when you're looking at spectrum monitoring to determine how often a signal occurs, if it's constant, if it's intermittent, and you can set your triggers to log those times. And sometimes you can record the spectrogram. That way you can go back and play it and review it to see something that you missed. So this is a good way to log spectrum traces and then go back to review it to analyze it further to see if you can determine any patterns or you could determine some additional signal analysis. Another newer feature is the real-time spectrum analyzer mode. This is a digital mode that's good for bursting or pulsing signals. A lot of times it allows you some IQ recording and some spectrum playback. Here you have two graphical representations. The one on the top is just a normal spectrum analyzer view where you had a complaint of one entity complaining that they were having interference. But again, you don't see the interference because it's covered by the victim's signal. So in order to actually see the interference, as I mentioned before, you may have, in years past, you may have to ask that victim to turn off so you can see the narrowband signal that's coming in on their frequency. But with the real-time analyzer mode, it allows you to see a signal within a signal or underneath a signal. And if you see the signal at the bottom, you can see that narrowband signal with inside that downlink signal that's on 877 megahertz. And you can see that, but you will only see that using the RTSA or real-time spectrum analyzer mode. But again, in years past, without this feature, you would have to have that offender turn off so you can see that narrowband source. Now, you still would have to have the victim turn the signal off so you can trace it, but just being able to see it is a big win and a big part of trying to identify something and then determine what the best course of action to resolve it. So that leads us into some of the tools that the FCC use for locating interference. Again, we use spectrum analyzers for measurements and signal classification. We use monitor receivers for signal demodulation and recording. We have different antennas, whether it's omnidirectional, broadband, and narrowband antennas. And then we have a list of each office has at least 3 or 4 mobile direction finders, which in those vehicles you see there. Each agent has a portable analyzer that we use for DFing with the different directional antennas. And then we also have, again, you see the TCI system there, which is a fixed system and deployable system that we set up temporarily or permanently to give us a fixed site, and we can control that via laptop, and we can get signal analysis, bearings, recordings, and other classification information using that fixed system. So again, using those tools, we get in this scenario of how do we locate the source. So basically, once we get a complaint and we get all the information from the complaint, we do some monitoring and some analysis of where the source could possibly be in or location. We take that information and we deploy agents in a particular area. We either have them connect to the victim's equipment, if possible, to get some kind of initial observation or initial bearing of where the signal is coming from. Again, we tap in or we do over the air. We select the appropriate frequency of interest. We choose the appropriate device, whether it's a spectrum analyzer or as a receiver. We set that tool up based on the specific parameters, whether it's bandwidth, sweep time, that will enable us to isolate what we're chasing. And again, if we don't know where it's coming from, we could start with omnidirectional just to see if we can get a good signal level. Once we determine that the level is good, then we can switch to a directional antenna. Once we switch to the directional antenna, we try to peak that signal source in a certain direction. So we slowly sweeping clockwise or counterclockwise to try to peak the signal level. Once we peak that signal level, we either plot manually on a map or we have some kind of software that can plot our points. So we'll take one bearing from one particular point, and then we'll move in the direction that we see the signal the strongest. And then we'll take a series of different points and we'll perform the same procedure. When we move to the next point, we'll slowly move counterclockwise or clockwise to try to peak that signal level and take that next point. Once we get 2 or more points that crosses, that's a general good fix. And then that'll get us in a location, whether that's mobile or if it's fixed site, then we try to use multiple fixed sites to see if we can get different crosses from the different sites. Using the mobile, we'll move around or move around on foot. Once we get to an area where we get cross bearings, we use the handheld equipment to isolate the source. We go into a particular building or we go into wherever we deem that the source is coming from, and we'll use the analyzers or the receivers to try to peek where that possible source could be coming from. Again, this is a graphical representation of a DF plot. This was done, like I said, it can be done by software. If you don't have fancy software, you can manually plot this on Google Earth or OpenStreetMaps. Some of the analyzers have mapping software that's associated with it, or you can download maps and upload it to the analyzer, or you can just print out maps and write that based on your GPS location of where you took your first measurement and the degree where you were pointing your antenna, where you observe the signal, and you plot it, and you take a series of plots again, and you go to that location from where it crosses, and then you use your equipment to try to peek it to a device, a tower, a building, or whatever you deem that's where you see the highest signal. Once you find the device, the building, or the object that's emitting the source of the signal, you want to conduct some additional testing. And one quick way to confirm that you found the source is to do what we call an on-off test. So once you isolate the particular device or entity or building, the tower where it's coming from, you will ask that offender to turn off their device. And a good way to document that is by using the max hold feature that I mentioned before. So you will have two traces. You'll have a real trace, and then you'll have the max hold trace. In this picture here, the green line is the max hold trace of when that source was active. And then the clear right or the yellow line is when it was turned off. So you can see a difference. When the signal was active, you had interference. And when you turned it off, the interference went away. So that's one way to identify and confirm you found the source of interference. And from there, you will go in and document what the device was, and you will find out if it was authorized. And then that will lead you into some further analysis or investigation of what was the cause and what ultimately you will do with resolving this issue, or whether you have them turn it off, whether you had them replace it, or they wasn't authorized in the first place and they should never have been on. But these are some of the basic techniques and some of the basic methods that we use, and I hope you can take part in some of this information that I share to develop your own techniques. And there's no way to do it, no perfect way to do it other than to get out and play with your equipment. You may develop some other techniques that works best for you. But again, the best way is always to share that information and talk amongst your peers and other people within the industry to see what equipment they're using and some of the techniques that they use that you can implement for yourself or your agency to help you resolve some of these issues. Again, this is just a basic overview of some of the stuff. I know it's a lot of information, but again, if you ever have the chance to partake in some of the other courses that us as the FCC provide, we'll get into more detail, and that'll lead into some other things. I think that was the end of my slides, but I appreciate your time. Again, I hope to see some of you soon in some of the upcoming USTTI presentations that we may have here in Columbia. If not, if you have any additional questions, there's my email address. I have been known to get a lot of emails from some of the students, and I always enjoy providing the responses to some of your questions. And if I can't get your answer, I'll try to get in touch with somebody that can answer your question. So I enjoyed my time here today. I hope you learned something from this. And again, don't be a stranger and don't be hesitant to reach out if I can be some assistance to you in the future.
Thank you, Shannon. Well done. As you said, a lot of information. The questions just seem to keep coming in. I think there are quite a few that you did cover or at least touch on, if you're willing.
Yeah.
Wouldn't mind just scrolling through, and if there's something that maybe you did not get a chance to address, go ahead and do that.
Yeah.
If you don't mind.
All right.
I know we're starting to run low on time.
No problem. I'll run through them as quickly as possible. Again, how do you pinpoint interference using the spectrum analyzer? I think I answered that just recently. Again, you get the analyzer, you tune it to the signal of interest. You start with the directional antenna, and you try to pinpoint where it's coming from, and then you go from there. In the event harmful interference, do you ask the operator to switch off their system? Yes. Harmful interference, and we find that, yes, it's imperative that we have them turn off their system. Unless it's another public safety entity, then it's going to get hairy because they have a reason to have it on. But ideally, yes, we have them turn it off, and we try to have them to have somebody on site to repair, replace, or identify what's causing the issue to alleviate the problem as quickly as possible. But ideally, if it's harmful interference, yes, we ask the operator to turn off as soon as possible. I think we talked about the cross-border stuff, it's basically coordination. You try to work with your other agency, and if not, then you got to get the diplomats involved, and it takes time, so it's not going to be resolved quickly. I think we answered about the co-channel interference. Is there a co-channel interference? Okay. I think we answered that was. Is there a special technique for measuring and localizing HF interference? For us here in the US, we have a certain group that handles HF interference direction finding. We don't. We do some minimum HF, but it also anything above 30 megahertz is where we investigate. But we have a HFDF team that does look at HF interference. But there is certain receivers. You got to have certain receivers and certain analyzers that operates in that frequency range. You're talking about loops, different kind of receivers, but basically you find devices that operate in that range, and you can use some of the similar techniques that I spoke with today, and just getting the right equipment and right antennas. How critical is signal ID and mitigating signal interference? It's not critical. It can help you speed up finding the source. If you can identify the signal, whether it's a call sign or you can determine what type of signal it is, you can find it without the signal ID, but it just will help expedite you finding out what that signal is. Are drones with directional antenna used to direct interference? So one of my partners is looking into last couple of years. He has been looking into FCC using drones to isolate interference. We haven't gotten to that point yet. Would it be helpful? Yes. A lot of times we can't see the signal on ground. And if you have elevation and we were able to send a drone up to get us a line of bearing or just get a better overview of the spectrum from what it looks like in the air, it would definitely be benefit, but we haven't gotten to that purchase yet. So hopefully soon we will use drones to help direction find. What technique or triangular method is that homing DF? So we use AOA for cars is AOA. For our fixed site, the TCI, it is a hybrid. So it's AOA, it can be TDOA if you have multiple systems, but for most of our DF equipment, we use angle of arrival. All right, let's see. What are good or RBW suite times and video bandwidth values for the best signal measurements? It's none that I can give you. Is all going to be based off the environment that you're in and different high power transmitters. Your location can add to how the spectrum looks. It could be a clean environment here and it could be a crowded environment there. It all depends. I always say start with auto and then let the instrument develop the best what it thinks and then you tweak it from there. So it all depends on your environment or where you're taking the measurements. Trying to see if anything, a lot of them was duplicates of what we talked about. This one, do you face RF ducting in the summer? Yes. We have issues where we get ducting, preferably still now in this is worse in the summer and the spring. It's hard. It's physics. So it's not much that you can do with ducting because it's only happen when the environment, what we do have where it cause havoc for hours or days. One is just to determine, a lot of people don't know how to determine if it's ducting or not. So we look at different propagation max to see that, hey, it only happens when it was warm or it was a breeze and didn't happen in other places. A lot of where we see ducting is in what we call the T-band, the old TV band, where we get high public safety agencies get interference from digital TV stations far off. We just tell them, we try to work with the licensees to see if there's any receivers or any adjustments that they can make on their end. And then we try to document that and send it over to the licensing bureau to see if any additional studies or anything that they can help to try to help these licensees with the ducting issue. But it's pretty much not much that we can do because we know it's atmospheric and you can't control the atmosphere. So it's not much that we can do other than try to help them determine when it is ducting and when it's something truly external that we can help with filtering or adding additional receivers maybe to help compensate for those times when they're receiving these ducting events. Someone says, can you elaborate on the training that you provide? Usually, since I've been here, we used to have 4 times a year, we will have FCC involved training where we give training on spectrum, detailed trainings on spectrum analyzer usage, direction finding systems, technical inspections. What else? It's a whole list, even satellite. We got a lot of satellite questions The FCC also provides satellite classes. So if some of the stuff that you were interested in, I know we got a lot of satellite questions, you may want to look for the course on satellite. So, but from DFing to spectrum monitoring to technical inspections to different equipment, we do a lot of courses on those. So I recommend, if it was just a touch, I'll try to touch a lot of areas in a little bit of time. But if some of the topics that I covered today, we go in detail. So if you ever get the chance to partake in some of those classes, please do.
Great. Great. Thank you, Shannon. Thank you for your patience with the questions and your diligence answering all of those. Huge virtual round of applause for Shannon today. Thank you.
No problem.
Yeah, quite a few questions. We did have quite a few attendees today, slightly more than yesterday. And I think from judging with the level of the questions, certainly those that are on the ground and dealing with a lot of the same issues that you deal with daily or weekly. Thank you. I always like to give the presenter last words of advice for the audience, closing our remarks.
Yeah, like I said, it's a lot of this is no right way to do it. Again, I've been here for 18 years. I'm still learning. And the best way is, again, information sharing information, detailing the events that you have, because not all, it's some of the stuff that I highlighted here today. That was just a cumulative effect of over years of me going out on different cases, me working with different people within my agency, and even talking to some of the students in UTI, USTTI that I come across. Because sometimes some stuff that you guys do is way advanced than what we do. And so I hope to implement some of the stuff that you guys bring to my attention to stuff that we do. So it's all information sharing and getting out there and experiencing the crazy environment that is RF, that's ever changing. So you can never know everything, and some of the stuff that you think might not cause interference will cause interference. So it's just be a student of the craft and continue to educate yourself and take part in stuff like this to gain as much knowledge as possible. So that's what I'll leave in part to the students. Again, I thank you guys for having me. Again, reach out to me if you ever have any questions or deem that I could be of assistance to you guys.
Thank you, Shannon. That was a point that was made yesterday, that with the ever-changing technologies and new tactics that seem to kind of hit the airwaves, you're always learning new things in the field, and it's a great opportunity to problem solve. And certainly with your experience, they don't stand a chance. So thank you. And we just want to thank everyone for joining us. Special thanks to the FCC. Again, we cannot provide this medium without the contribution and the time, most importantly, from the FCC and from Shannon today. Thank you so much. Just before we end, we just wanted to inform everyone that tomorrow we will hold the third webinar in the series. It will explore the various popular testing tools used for spectrum monitoring and direct confining, much of which Shannon touched on today. It will also address new trends in these testing tools while sharing the latest methodologies, providing specific examples from real interference investigations. The webinar will begin at the same time as today, so we will hope you will be able to join us. Look out for another email if you still need to register for tomorrow's webinar. So with that, I want to thank everyone for joining us, and we will sign off in hopes of seeing you again tomorrow. Thank you, Shannon. Thank you, everyone, for being here, and have a wonderful rest of your evening, your morning, your afternoon, wherever you're joining us from. Take care, and thank you.
Thank you.